You've probably done it at least once. You put something in the microwave, hit start, and within seconds, sparks. A loud pop. Maybe a small flash of light inside the machine. You yanked the door open and pulled the metal out, heart racing slightly. But why? What is actually happening inside that box when metal enters it? The answer involves physics that most people have never been taught. And once you understand it, you'll never look at your microwave the same way again. To understand the problem, you first need to understand how a microwave actually works. Despite the name, it doesn't heat your food with heat. It heats your food with radiation, specifically microwave radiation. A component called a magnetron generates waves of electromagnetic energy at a frequency of around 2.45 gigahertz. These waves pass through your food and cause water molecules inside it to vibrate rapidly. That vibration generates heat. That heat cooks your food. It's fast, efficient, and completely invisible, which is exactly why what happens next is so surprising. When you place a metal object inside a microwave, something very different happens. Metal doesn't absorb microwave radiation the way water does. Instead, it reflects it. The free electrons on the surface of the metal react to the electromagnetic field by moving rapidly back and forth. This movement creates its own electrical currents on the surface of the object. But here's where it gets dangerous. If the metal object has sharp edges, points, or thin sections, like the tines of a fork, the crinkled edge of aluminum foil, or the handle of a metal spoon, those electrical currents concentrate at the tips. The energy density becomes so high that the surrounding air breaks down. It ionizes, and ionized air conducts electricity. That's the spark you see. Those flashes aren't just dramatic. They're miniature electrical arcs, the same phenomenon that produces lightning. And just like lightning, they release sudden bursts of intense heat. That heat can char the inside of your microwave, damage the magnetron, and in extreme cases, ignite materials nearby. But here's what most people never think about. Not all metal behaves the same way in a microwave. Smooth, rounded metal objects with no sharp edges or thin sections can actually reflect microwaves without producing sparks. This is why the interior walls of your microwave are made of metal. The chamber is essentially a metal box, designed to reflect the waves back into the food, rather than letting them escape into the room. The door contains a metal mesh with holes small enough to block microwaves from passing through, while still allowing you to see inside. Your microwave is already full of metal. The difference is geometry. A smooth, thick metal bowl with no sharp edges might survive a short microwave session without sparking. But a thin aluminum takeaway container with crinkled, folded edges? That's a completely different story. The sharper and thinner the metal, the more concentrated the electrical charge, and the more likely it is to arc. There's a second problem that has nothing to do with sparks. Metal reflects microwaves rather than absorbing them. When metal blocks the waves from reaching your food, parts of your meal stay cold or undercooked, while the microwave works harder than it should. Over time, running a microwave with poor energy absorption can stress the magnetron and shorten the machine's lifespan. So the rule isn't really no metal ever. The rule is more precise than that. No sharp edges, no thin sections, no crinkled surfaces, no metal that could concentrate electrical charge into a point small enough to ionize the air around it. The sparks you've seen aren't a malfunction. They're your microwave telling you exactly what it was designed to tell you, that the physics inside that box is more powerful than it looks. Next time you're about to reheat something, take a second. Check the container. Look for foil edges, metal handles, or anything with a sharp point. Because what's happening inside that humming box on your counter isn't just warming up leftovers. It's controlled electromagnetic physics. And metal is the one thing it wasn't designed to handle. And here's something I'm curious about. Have you ever accidentally put metal in a microwave and seen the sparks? What happened? Drop it in the comments. I have a feeling almost everyone has a story. If this changed how you see the most common appliance in your kitchen, hit like and subscribe to Everyday Objects, Extraordinary Stories,
for more stories about the hidden science shaping everyday life around us.